This video starts on page 12 of your packet 1D, and it's got the problem of the day in it. Solve the system of equations. You can set up a table and try to figure it out. And we've got two questions here. The second one, number 4, says to graph the equations. If you're going to use y equals mx plus b, which I highly recommend, make sure you're stating what m and b are, and then go to the graph paper and graph them. So problem of the day, page 12. Do that on your own and be ready to have that finished for class tomorrow. Solving systems of linear equations using algebraic methods, the elimination method. This is 5.2 in the textbook. So chapter 5, section 2, 8th grade textbook is where you'll find systems of equations. So we've done a table method. We've graphed them. Now we're going to do the elimination method. You have learned to solve systems of linear equations using a table of values and graphically, but you may need to use a more systematic algebraic approach. So this is the algebraic way of solving it. Consider the system of linear equations. X plus y equals 8, equation 1, and x plus 2y equals 10, equation 2. You can represent these equations using bar models, and it's hard to see, but this is an x plus a y equals a total of 8, and an x plus 2 y's equals a total of 10. The difference in the length of the bars, which we can see here, the difference in the length of the bars is just that one y, and the difference in their values, 8 and 10, is 2, so y must equal 2. From the bar models, y is equal to 2. 10 minus 8 is 2. Look again at the bar model representing equation 1. So now they've substituted back in y equaling 2. So x plus some 2 equals 8. Well, then x, if I take 8 and subtract 2, I'm going to get that x equals 6. So I've solved the system of equations for the answer, the ordered pairs, x equals 6, y equals 2. Plugging that back into both equations, you'll see that that works. 6 plus 2 times 2 is 4, does equal 10, and 6 plus 2 does equal 8. Algebraically, you can use that same approach, not drawing the bar model. So x plus y equals 8, second model, x plus 2y equals 10. Both equations have an x term in them. If you subtract the two equations, you will have one equation only with the variable y. And we do it like this box over here, and writing the equations vertically, not horizontally like this. So I'm going to subtract the equation 2 minus equation 1. Well, minusing equation 1, you have to use the distributive property. Caution, 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 caution. When you subtract one equation from another, remember to use parentheses to group the expression after the minus sign. It's like having a negative 1 here, and that minus or negative goes to the x and the y, which you can see here, negative x minus y. Well, x minus x, those cancel. That's what we want to do. We want to eliminate one of the variables. So 2y minus a y gives me a y, and 10 minus 8 gives me a 2. So yes, y does equal 2. The x has been eliminated. So I'm going to practice this in a couple of more examples here. I'm going to take equation 2 and subtract it from equation 1. So 2a plus 3b, I'm writing it over here, equals 29. And I'm going to subtract 2a. So I'm going to subtract this equation from equation 1. So I've got to distribute this negative to everything in equation 2. So I get negative 2a, and negative times a negative gives me positive ab, and negative 1 times 17 would give me negative 17. So everything in equation 2 became its opposite. Subtracting means add the opposite, right? So now they're their opposites. So 2a's, take away 2a's. Oh, I've eliminated a. I've eliminated one of the variables. 3b's plus another b gives me 4b's. And 29 take away 17 is 12. Solving the equation, I get b equals 3. Well, I'm not done. I want to know what that a is. And yes, this could have been an x and a y instead of an a and a b, but we're solving for a and b here. So I know b is 3. Choose one of the original equations and plug the a or the b in to find the a. I'm going to go with the positive one, which was 2a plus 3. Oh, I know what b is. 3. 3 times 3. b is 3. Has to equal 29. Well, this is 9. 2a's plus a 9 equals 29. So I'm going to subtract 9, and I get 2a's, cancel, equals 20. Divide by 2, divide by 2. I get a must equal 10. Well, I'm going to check in the equation 2 these two values. I think the solution is a is 10, a comes first, and b is 3. So I think the solution is 10, 3. I'm going to put it into equation 2 mentally. Listen to what I say. So 2 times 10 is 20 minus 3b, that's 17. Oh, yes, it works. I could put it back into the top one. 2 times 10 is 20, plus 3 times 3 is 9. 20 plus 9 equals 29. Yippee, right answer. The solution is 10, 3. Example 2. I'm going to, I don't have to change anything. I'm just going to add these two equations together because I have a negative y in the first equation and a positive y in the second. And if I add those, opposites cancel. Oh, I love it when they already have an opposite one in it. So 2x and 3x gives me 5x equals 15. Oh, easy peasy. Divide by 5 and I get x equals 3. Now I've got to substitute that back into one of the equations. I'll choose the first one. I could choose the second one, either one. 2 times 3 minus y equals 2. Well, that's 6. 6 take away 4, right, is going to give me 2. I know this answer, y equals 4. Not negative y. Y equals 4. And checking it back in there, 3 times 3 is 9, plus 4 does equal 13, and 2 times 3 is 6, take away 4 is 2. So it works in both equations. That's my check. I did it mentally. You heard me say it. So the solution is 3, 4. Some people like to write the solution this way. X equals 3. Y equals 4. Excuse me. So x equals 3 and y equals 4. Next page. Solve system of linear equations without common terms using the elimination method. So equation 1 here is 2x plus 5y equals 11. Equation 2 is 9x plus 2y equals negative 12. Let's eliminate the x. Well, one of them has a 2 in front of it and one of them has a 9. But I could get those to cancel if I make those both 18s. If you multiply 2x by 9 and the 9x by 2, you will get 18 in each case. So you can multiply both sides of the equation 1 by 9. And yes, sometimes you have to do this. You have to find a common factor for them. And equation 2, multiplying everything by 2. I would go ahead and multiply everything in equation 2 by negative 2, probably. And you can see subtracting versus adding here, this handwriting over to the side here. So 9 times 2 would give me 18, and 9 times 5y's is 45y's, and 9 times 11 is 99. Subtract, 2 times 9 is 18, 2 times 2 is 4y's, and 2 times negative 12 is negative 24. And yes, I'm subtracting those, and those are going to cancel. Or adding them, okay, you can think of it either way. 18x minus 18y, so you can think of, oh, I've got to distribute this negative. I go ahead and do it automatically. I go ahead and distribute that negative. I don't write it out like this top example here. I don't write it out with this parentheses like this. I go ahead and I say, you know what, I'm just going to multiply by negative 2 to start with. And I distribute a negative immediately and get negative 18xy, negative 4y, and positive 24. I do it like this. Then those will cancel, and 45 take away 4 would give you 41. 99 plus 24 is 123. Dividing by 41, I get y equals 3. Plug that back in. 2x. Go back to the original equations, not the ones that I multiplied by, not their equivalent, not the larger equivalent equations. They look larger, they're not. They're the same value. 2x plus 5y equals 11, and 2x plus 5 times 3 equals 11. So subtracting 15, I get x has to equal negative 2. So it's the ordered pair negative 2, 3. Or you could write it out, x equals negative 2 and y equals 3. I like to put it in the ordered pair like that. I like to multiply by the negative immediately, multiply by negative 2 to get one of those to cancel. So let's see here. In number 4, oof, I don't even have m and n's on the same side, so you got to do that first. So 7m, so this second equation would be 2m minusing 3n's from both sides, minus 3n equals 13. So I have a negative 3n and a positive 2n. Well, since one of them's positive and one of them's negative, I'm going to eliminate the n's and get those to both be 6's. I could, however, eliminate the m's and get those to be 14s, but they're not opposites already. It's a positive 7m and a positive 2m. So since my n's, one of them, because I had to change this equation and move this negative 3n over, right? Because you want them to be in the same order. M plus n equals a constant. So I got a positive 2n and a negative 3n, so I'm going to multiply these to make the coefficients of the n's to be 6's, which means equation 1 here I'm going to multiply by 3, and equation 2 here I'm going to multiply by 2. So 7m times 3 is 21m, plus 3 times 2n's is 6n's. And 3 times negative 8 would give me negative 24. 2 times 2m's would give me 4m's. 2 times negative 3n would give me negative 6n's. Yay, those are going to cancel. And 2 times 13 would give me 26. So I have 21m's and 4m's, 25m's, equaling negative 24 and 26 different sign subtract. So you get 2. Right? So I get 2, and when I, oof, is that right? Oh, it's negative 13. Woo, negative 13. That's a negative 13. I didn't think that was right. That's not going to be a very nice number, 2 divided by 25, but 50, negative 50, same signs, add and keep, that's going to be negative 26. Oh, got to be careful with those negatives. Dividing by 25, I get m equals negative 2. See how easy it is to lose those negatives. Now, plugging that m back in, I'll just use the first equation here. 7m's 7m, so 7 times negative 2 plus 2n's equals negative 8. So I've got negative 14 plus 2n's equals negative 8. I'm going to add 14 to both sides, add 14 to both sides, and I get 2n's equals 6. Dividing by 2, I get n equals 3. So m is negative 2, and n is positive 3. Am I sure of that? Let's plug those into the second equation, the original second equation. So m is negative 2. So 2 times negative 2 would be negative 4 equals 3 times 3 is 9. 9 take away 13 is negative 4. Oh, negative 4 equals negative 4. So yes, it does work in the original given equation, 2m equals 3n minus 13. You want to be careful that you're checking the original equations in case, like I did here, I multiplied 2 times a positive 13 when it was supposed to be negative 13. So you want to be careful with your math. Oh, look at this. I have y's that are opposites here. Almost. So the only thing I have to do at number 5 is multiply the top equation by a 2. So that would give me 6x and negative 4y equaling 48. So these 4 y's will cancel. I'm not even going to write that second equation over again. So 6x and 5x gives me 11x equals 48 take away 4 is 44. So that's very easy. X equals 4. I'm going to plug that back into the top equation. 3 times 4 minus 2 times some y equals 24. 3 times 4 is 12. I'm going to subtract 12 from both sides. And I get, very careful, negative 2y equals 12. Dividing by negative 2, and I get y equals negative 6. So I think the ordered pair is x equals 4, y equals negative 6, or 4, negative 6 is the solution to this system. Let's just put it in the second equation. 5 times 4 is 20, and 4 times negative 6 is negative 24. 20 and negative 24, yippee, makes negative 4. So we've got the right solution, and let's be done for today. That's it for today's video.